أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم السلام عليكم ورحمة الله. Today we will solve problem 2 still on uniformly accelerated motion. We have A and B. The A part says an object start from rest. Remember what we said in the class, that whenever they mention this start from rest, anything start from rest, it means your V initial is 0. So from there we obtain our first parameter. And then with a constant acceleration of 8.00 meters per second square. So this is our uniform acceleration along a straight line. So the first question says we should find the speed at the end of 5.00 seconds. This is your t or delta t. Anyone you use is correct. The average speed for the 5-second interval, and then the distance traveled in the 5 seconds. Okay, let's start immediately. A solution, we're going to write a solution here. Next, our A part of the problem, okay, we are given an initial velocity v sub I as 0, then acceleration is also given as 8.0 in meters per second square. Then Roman number 1, we are asked to get the Roman number 1. Roman number 1, according to Roman number 1, our time is 5.00 seconds, and they want us to get the velocity. This speed dimension, it means magnitude of velocity, because magnitude of velocity is the speed. So which formula should we use? Yes, you know, choice of formula is very important. If you can see, we are not given the distance traveled, so we avoid equation with s, and yes, and that to find that velocity, you know that velocity is final velocity, and to find that velocity you need two equations. You need v sub f equals v sub I plus at, or v sub f squared equals v sub I squared plus 2as. But this s is the distance traveled, and we don't know that distance. Because we don't know the distance, we cannot use this formula to find the final velocity. So we resort to this one and say our final velocity is v sub I plus at, and this is equal to our v sub I is 0 plus our acceleration 8.0 multiplied by our time 5. This will give us, just take your calculator in case you will be confused. Press the 0, then plus 8.0 multiplied by 5. See, now you press the equality sign and you can see that your answer is 40. So this should be 40. I remember the quantity is velocity, 40.0 in meters per second. So it started from rest, and after 5 seconds the velocity is 40.0. Now Roman number 2 says, what should we find? The average speed. MashaAllah. Okay, average, if you know the initial speed, you know from 0 to 40, the speed has not just spontaneously changed from 0 to 40. Definitely it changed from 0 to 1, and at some point is 2 meters per second, 3 meters per second, and on until it get to that 40. So how do we get the average speed? Now the idea is that if we know the initial speed and the final speed, we can add them together and divide them by 2. That will give us the average speed. Remember, speed is the magnitude of velocity. So and this is what they are asking. Okay, this is That is what they are asking, the magnitude of velocity. Okay, so we now say our V average is equal to half into, meaning you are dividing by 2, into V final plus V initial. If you like, you can write V initial first, then V final first. This will not change the result. This is equal to half into V final. You just got that at as 40.0 meters per second, plus V initial was 0 meters per second. Okay, now this means 40 plus 0 is 40, and then what you obtain, you divide it by 2. This will give you 20.0 in meters per second. So the average speed is 20.0 in meters per second. If you feel that you will be confused, because sometimes this may not be 0, so my advice is open bracket, just open bracket. Okay, press 40 plus 0 or whatever the number is, close bracket, and divide by 2. Okay, when you do that, look at it. If you do it like this, you are still finding the average, and when you press equality sign, 20 appears. So your result is 20. Then how do we find the average? How do we find, because this one we found, the second one, average speed. The next one said we should find the distance s. So the distance, to find the distance s, you see, we can use this formula, Roman number 3. We can use this formula that say V sub f square equals V initial square plus 2as. You see, because we know the V final, we know the V initial, we know our acceleration, so we can find s. Okay, let's try to make s the subject of the formula. First of all, we will bring this one to this side and it becomes negative. So we have V sub f square minus V initial square equals 2as. Then we will divide both sides by 2a, both sides by 2a, so that 2 cancel 2, a cancel a, and we have only s left on one side. Therefore, our s is equal to V final squared minus V initial squared divided by 2a. Moving on, this is equal to our V final. We got the V final as 40. So this means we have 40 squared minus our V initial. Remember, it was 0. 0 squared minus, okay, 2 into A, and our A, you remember, look at it, the A is acceleration 8.0. This is 2 into 8. Okay, so moving on, we know that this one should this one, since it's 0, this one will vanish. So I only have 40 squared divided by, then in the denominator is 2 times 8, and this will give you 16. Okay, but because I know some will be confused, so I will just leave it like that. Then you bring the calculator, you simply press your 40 squared divided by 2 open bracket 8 close bracket. Can you see that? You see, 40 squared divided by 2 open bracket 8 close bracket. Now press the equality sign and you see your answer is 100. So this means the distance travel is 100 meters. Distance travel 100 meters. With this one, we have successfully solved the A part of the problem, and we can proceed to the B part of the problem. Okay, let us bring problem B. Problem B says a bus moving in a straight line at a speed of 20 meters per second begins to slow down. Okay, remember what we said in the class, that when they say an object begins to slow down, at that point, okay, at that point the velocity before that point should be taken as our initial velocity. So this is our V sub I. Begins to slow down at a constant rate of 3.0 meters per second each second. Find how far it goes before stopping. So when it stops, remember the final velocity is 0. Now one may rationally ask, what about this 3.0 meters per second? Why should it not be our final velocity? I said this one is the magnitude of acceleration, because they did not stop at just 3.0 meters per second. They told you that 3.0 meters per second each second, and this each second is also another per second. So if you combine it with this per second, okay, it means 3.0 meters per second squared. You have per second, per second, per second squared. So this is the magnitude of the acceleration. It is telling you that the bus slows down at this rate, meaning let me illustrate that. Let's say this is the end, this is the point. When the bus reaches this point A here, it begins to slow down. So at this point, its velocity was 20 meters per second. Okay, so 1 second later, the velocity drops by 3.0 meters per second, and it becomes 17 meters per second. 1 second later, this 17 will drop by 3 and it becomes 14 meters per second. 1 second later, this 14 will drop again by 3 and it becomes 11 meters per second, again and again until it stops. Okay, so this is telling you the amount by which the velocity changes each second, and that is the measurement of acceleration. Acceleration, remember, is change in velocity divided by time it takes. So the velocity changes by this magnitude, so this is your 3.0 meters per second. Each second means 1 second, a 1 second interval, and when you divide 3 by 1, you get 3.0 meters per second divided by second, meters per second square. So this one, I am trying to convince you, okay, that the quantity given there is not velocity, is acceleration. Okay. um Another thing we should know from here is that this acceleration should be negative, should be a negative acceleration. It means it should be minus 3 meters per second square, since the object is slowing down and not speeding up. So when we are using it, it will appear as a negative acceleration. Now our question is our question will now be that how do we find the distance? Okay, remember our equations. V sub I sub f equals v sub initial plus at, and then v sub f squared equals v sub I squared plus 2as, and then s is equal to v sub I t plus half at squared. Okay, now to find distance, you need this one and this one. Okay, can I use this one? I cannot use this one because I was not told the time it takes to stop down, to stop, sorry. So it means I will not use this formula. I resort to this one because this one has no t. All the parameters here, no time is given, so I will not use this one. I will use this one to get s. I know the final velocity. The final velocity is 0. I know my initial velocity. My initial velocity was my initial velocity was what was it, 20 meters per second, right? So I know my acceleration, right? My acceleration is 3.0 meters per second squared. Okay, So, and I say that this acceleration has to be negative since it is slowing down. So with this one, we can solve our problem B. So let's identify the parameters we are given. First of all, our V sub initial is 20 meters per second, and our V sub final, because at the end it stops, this is 0 meters per second, and then we don't know the time, but we know the acceleration is negative 3.0 meters per second squared, because the car or bus slows down. Okay, now, how do we find S? We use this formula: V sub F squared equals V sub I squared plus 2AS, because we don't know the time, so we will not use the one that has time. Make S the subject of the formula, and your S is equal to V sub F squared. We did this before, V sub I squared divided by 2A. Let us continue and see what we will get. This is equal to our V sub F, this is 0 minus V sub 0 squared minus V sub I 20 squared divided by 2 into my acceleration is negative 3.0. Again, since this is just 0, so this cancels, but the minus here will not vanish, it remains. So I have minus 20 squared divided by 2 into minus 3.0. You know, I can clear the bracket and get 6, but I am afraid negative 6, but I am afraid some students may be confused, so I will leave it like that. So you now bring your calculator and press negative 20 squared divided by 2 open bracket negative 3.0 close bracket. This is what you will get from your calculator. Okay, negative 20 squared divided by, then you now press the equality sign and you will see you have 66.67 approximately in meters. This is equal to 66.67 approximately in meters. Okay, suppose you did not put the negative sign for the acceleration, you will get a negative value here. If you don't do that, a negative value for distance, and distance is always positive. It is displacement that can be positive or negative or even zero, but distance is always positive. I hope this problem is clearly understood. Assalamu alaikum wa rahmatullah.